Good morning. Welcome to factoring part 3. This is our third segment lesson. I guess that's kind of like the numbering has gotten kind of messed up, trying to split it up for like 50 minutes every day instead of 90 minutes every other day. But it is really the third part. And the topic in today's lesson is factoring with a leading coefficient, not 1. Now, I threw some vocabulary out there that you may or may not know. Leading coefficient. It's kind of intuitive if you let yourself stop and think about what the words mean. Leading means like going in front, like the leader goes in front, and a coefficient is the number in front of the variable. So leading coefficient would be the number in front of like the first variable. It's the first number you see. So it means it's not 1. But before we get into that, this is like a good moment to pause and just do a recap of what have we covered in factoring so far. So we can get our heads around where we've gone, and that'll prepare us for taking the next step. My goal is to just get through the strategy for factoring with a leading coefficient, not 1. We're only going to do one example in this lesson. And then in the next lesson, I will work through several more examples and we'll get to some practice. So the first part of the recap here is, I don't know why I put that vertical line there. Let's try this again. Is if you are doing greatest common factor only. This was the candy tax. This is, you're looking at an expression and you're just looking to see if all the terms have a common factor. So an example might be 4x to the third plus 2x. And you can do this with your prime factorization, or you might look at it and just see, oh, there's a common factor of 2, because you can factor 2 out of 4, and there's a common factor of x. Or you could do it this way and break it down into your prime factorization. And you can see that we have a common factor of 2, which would come out of the parentheses, and a common factor of x, which would come out. And then we can see what's left. We're left with 2x squared. And then on the other side of the plus sign, remember, if you factor everything out, you're not left with a 0. You're left with a 1, because you could have written like 2 times 1 there. Okay, and so you're left with a 1. Now, that's just doing the greatest common factor, and so you get the greatest common factor, and you're done with that problem. Then we looked at this. We looked at factoring trinomials. Remember, trinomials are when you have the three terms, and the leading coefficient, or the a value, was equal to a 1. So that would be something like this. And you could try to do greatest common factor. Okay, you look at it, but there's no greatest common factor. And the leading coefficient here is 1. I threw that vocab out at the beginning of this lesson. Leading coefficient is the coefficient that leads the way. So it's the very first thing. And in this case, the leading coefficient is a 1. And this is the one where you set up your parentheses. You factor the x squared into x times x. So you know that that's going to split into x times x, because when you FOIL it or distribute, the x times x is going to give you the x squared. And then you have to train yourself to ask the question, what are 2 numbers that multiply to give me negative 15 and add up to give me negative 2? So you might do some scratch work off to the side. And you say numbers that multiply to 15 would be 1 times 15, not 2 times anything. And then we have 3 times 5. And 3 and 5, that I can get a negative 2 out of if I do a positive 3 and a negative 5. Positive 3 plus negative 5 would give me negative 2. And positive 3 times negative 5 would give me negative 15. And so I'd have plus 3 minus 5. And the 2 factors are x plus 3 and x minus 5. So you have a factor of x plus 3 and a factor of x minus 5. Then in the last lesson, we did what we call the difference of squares. And I'm going to abbreviate that DOS for difference of squares. And we'll look at this example. So you recognize when you're doing the difference of squares, the difference means subtraction, and you're subtracting two things where everything is a perfect square. So 3 times 3 is 9, x times x is x squared, and 4 times 4 is 16. And so that gives us the difference of two squares. And when you factor that, you basically take the square root of everything. So the square root of 9 is 3. The square root of x squared is x, and you get that goes in two places. And then the square root of 16 is 4. And then this factors into something called conjugates, where one of them is a plus and one of them is a minus. And again, the word for that was conjugates. Now, in the next example, we're going to shake it up a little bit, okay? And we can actually combine these. So over here on the left-hand side, well, we'll do it on the right-hand side. I'm going to factor like the number 12. And we'll factor it into 2 times 6. And we know that that is correct factorization. But if you think back to the earlier ones, like a couple lessons back, I said when we're factoring, we're actually looking for what's called the prime factorization. So you could look at this and say, yes, it is factored, but I can factor it more, because I can take the 6 and factor that into 2 times 3. And the reason the prime factorization is so important is because there's only one of them. So everybody in the class can factor 12, and we're all going to end up with 2 2s and a 3. Maybe not in that order. Maybe you have like 3 times 2 times 2, but like those are the same numbers. So we are going to combine, I'm going to put the D on that, and take a look at this example. And if we look at this, you might notice that there is a common factor of 5. So I'm going to factor the 5 out. If I have 5x squared and I factor out a 5, I'll be left with x squared. And if I have a 20 and I factor out a 5, this is where you can see factoring is related to division, because I would do 20 divided by 5, and that's going to tell me what's left. Now, and you get the 4. Now, if you look at it, you've got two factors. You've got a factor of 5, and the other factor is x squared minus 4, kind of like having the 2, and then the other factor is a 6. That if I look at the x squared minus 4, I actually notice that this is the difference of two squares. So just like I can take my 6 and factor that more, and just like bring down the 2, I can take my x squared minus 4 and I can factor that more. X squared factors into x times x. And then the 4 would factor into 2 times 2. One of them's a plus, one's a minus. And just like over here, we want to remember that we did have that factor of 2. I do have that factor of 5. And this actually has 3 factors to it. So I'll let you kind of look at it for a moment and convince yourself there are 3 factors. You have a factor of 5, a factor of x plus 2, and a factor of x minus 2. Factors are things that are multiplied, and so we've got multiplication going on there. Now let's look at the new content. So that was like a recap of everything we've done so far, and what I did there was I did a little reteach. So if you missed one of the lessons or you thought that you were weak on something, I'm just kind of putting it out there again so you can hear it again. Now I want you to think about this problem. This is a trinomial. I know it's a trinomial because I have 3 terms, 2x squared, negative 5x, and negative 12. Terms are things that are added and subtracted. So if you were to start doing this problem, you might approach it the way that we approach the other trinomials. And so you might do this. You set up your parentheses. And then you ask yourself, what are 2 numbers that multiply to 12 but add up to 5? And so you start going in with this. Like, okay, numbers that multiply to 12. 1 times 12, 2 times 6, 3 times 4, and then you hit the 4, and so you're out. And you start looking at them. Is there any way you can get a 5? If I add these, I get 13. If I subtract, I get 11. If I add these, I get 8. If I subtract them, I get 4. If I add these, I get 7. If I subtract them, I get a 1. And there's no way to get a 5. And what you realize is that this method doesn't work. And the reason it doesn't work is because of that 2. So let's just go back and do a little bit of vocab. The leading coefficient is not 1. In this case, the leading coefficient, or the coefficient out front, is a 2 instead. And what that does is it means that our strategy that we were using doesn't work. Now, there are several strategies for factoring a problem like this. These are some strategies that I've used, and they're strategies that I've taught or I've been taught. One of them is trial and error. This is actually the preferred method of advanced classes. And the way that works is you guess and check at what you think goes in the parentheses. And so you guess some stuff based on the numbers. Like, you're not going to do like random guessing, but you have some ideas. You plug them into the parentheses. You would do the foiling together. So you kind of do this off to the side. And you would see if it checked. And if it didn't check, you would like cross out that one and you would guess something else. And you would, okay, and that's how I was taught. I was not taught any other method for doing this, and I was taught trial and error. And so it's kind of long and it requires a lot of patience, but what it does is it develops your ability to just see the answers. So some of you might notice your neighbor just seems to be able to factor. They can just see it. They just see the answer. There's a chance that if that's your neighbor, that they were taught trial and error back in Algebra 1. And so they've developed it, but it does take time. The European method is actually really cool. It's also called the OOPS method because you intentionally do something wrong at the beginning and then you fix it. The box method is a method I learned from Miss Bradford. If you know who she is, she's awesome. She runs the CSS. She's the head of CSS here at Atlantic Coast. And she would teach her students to factor using the box method. Then there's slide and divide. There's also factoring by grouping. And I probably should have put that on here. Oh, look, it appeared. Option 5, factoring by grouping. I've done factoring by grouping. I've actually been observed teaching that method. It's really, like, it's very algebraically sound. It's the kind of method that you can explain how it works and why it works. But it's also kind of long and it involves a lot of steps. So most students don't prefer it. In this class, this year, we are going to be using slide and divide. Now, I want to be clear about this. You can use any method you want. So if your Algebra 1 teacher taught you how to factor using any of these methods, you are absolutely 100% free to use any method you want as long as you can make it work. That's okay. But in this class, when I'm explaining it and I'm demonstrating it for consistency, I'm going to use slide and divide. Okay, so I just want to be clear, you don't have to do it this way. I'm going to put it out there. I'm going to be consistent with how I present it in class, but I know there are other methods and I'm okay if you use them. All right, so let's talk about slide and divide. We're going to go through one example problem with slide and divide, and then that's going to wrap up the lesson for today. So as always, I'm going to give you the steps. I'm going to try to keep this color-coded and work an example problem off to the side so that you are able to see like what the steps look like and what they correspond to, and that should make your notes easier. If you print the notes off of Teams, like they scan color-coded, which is really nice. So you can actually see the colors in my original notes, or you can watch the video. You can take a picture of the video. I don't care what you do. Just trying to help you out with the coloring here. So step number 1 is you are going to slide. This is the slide part of slide and divide. You're going to slide your A value to the end by multiplying. So I put that in green, and then I'm going to show you in green what I mean by it. Because if you only write down the steps, then like later you said slide A to the end by multiplying. What does that even mean? What am I supposed to do? So we have our ax squared plus bx plus c, or in this case, like plus negative bx, okay? Negative. This is my A value. A is 6. I'm going to take 6 and I'm going to slide it down to the other end, and I'm going to slide it by multiplying. So I'm going to do 6 times 3. So I'm going to take the 6, I'm going to slide it down, Okay, I'm going to do like a little times 6 in there. And when I do that, I will get x squared minus 7x minus 18. Now I want to be clear. This is a totally different problem than the problem above it. I'll repeat that. This is a totally different problem than the problem above it. But it's a useful problem. It's a problem that's going to help us get to the factoring for the problem above it. We just have to make sure we follow the rules and follow the steps. But I don't want you to think for any moment that these are the same problem or two different ways of writing the same problem. And if you ever have Mr. Frenzel for pre-calculus, don't show him what you're doing here. Okay, just like it's our secret. Step 2. This is why I like slide and divide, because then for step 2, I can say factor as before. And so I don't have to teach you some other strategy for factoring, because we already know how to factor something with a leading coefficient of 1. So what this strategy does is it kicks it back to something you already know, which makes it more comfortable, and it's going to do the hard part of the problem like in an environment that you already know how to deal with it. So we are going to factor this by finding two numbers that multiply to 18 and add up to -7. So you can do a little scratch work. We have 1 times 18, 2 times 9, 3 times 6. And the one that gives us -7 would be if I had a +2 and a -9. So this is going to be x plus 2 and x minus 9. Now, this is not the end of the problem, because we're in like a totally different problem. The green problem is different. And so if we change the problem at the beginning, we have to change it back in order to get back to the answer that we want. So the way I'm going to phrase this, I'm going to convert over to purple here. We are going to undo our multiplying, and this should make sense, this is like connected, by dividing by a. By dividing by a. So the number that we multiplied by is going to be the number that we divide by. Now what am I dividing by a? I'm going to divide these numbers by a. So as I write that, and I give you guys a chance to write it, we multiplied the 6 into the 18. So that's where we need to divide it out from. We need to divide it out from the 2 times 9. So we multiplied the 6 in, we got the 18. Then we kind of split up the 18. So we need to make sure we're dividing it out of the 18, but we've got to do it in like 2 pieces. We have to do it with the 2 and the 9. And that's going to undo this so that we get back to where we were. Now the next step in this is actually, you usually don't have to do it, okay? So step 4, most of the time you're not going to need to do this. You have to simplify the fractions. And so we're going to simplify 2/6, and that simplifies to 1/3. And then we'll simplify 9/6, and that simplifies to 3/2. You can use your calculator to do this. So your calculator will simplify the fractions for you. Yeah, so you don't have to worry about that. You can punch that in. That's not cheating. And then we have to slide it back. So this sliding process that we did, where we kind of kicked this 6 down, that the 6 really belonged up front. Okay, it really belonged in the front. We kicked it down here. We're messing with it down here. Now we need to kick it back. So in this first step, we're multiplying and we're sliding. Here we're undoing the multiplying, and now we're going to undo the sliding. And we'll do that in blue. We are going to slide the denominators back. Denominators back. And here's what we mean. We are going to take the 3, and we're going to slide it back in front of the x. So that's going to be 3x plus 1. So you're just kicking that back, and we're going to take the 2, and we're going to slide it in front of this x right here. And we'll get 2x minus 3. And now we have successfully factored 6x squared minus 7x minus 3. And that's your process for slide and divide. I actually really like it. And I'm saying that as somebody who was taught trial and error and who has pretty good intuition when it comes to factoring. I actually like factoring this way, especially when I have numbers that are kind of big, because it gives me a foolproof way to get those factors. Most common mistake is not simplifying the fractions. And not dividing. Like, students stop after step 2, but the name of the strategy is slide and divide. So make sure you are dividing. Now, that's the first example. That's the example where I'm giving you all the steps. That should set you up to start your homework and try your homework out. But you might get stalled on some stuff because we actually have a lot more examples to cover, so you can see what that looks like. But we've gone far enough for today, so I'm going to let you meditate over these steps and burn them into your brain, and we'll pick up with it next class.